Okay, let's find some probabilities from a probability density function. So here we have the tread life density function. And we're going to find some probabilities. That the tread life is first at most 30,000 miles. Well, straight away, I can write that as probability that we have less than or equal to 30,000 miles. Notice that I almost went and wrote 30,000 here, but reading the question carefully, I can see that tread life is measured in thousands of miles. So I actually want P at x is less than 30. And this is a PDF, so this is going to be the integral from 0 to 30 of the function given there. Okay, before calculating this, let's just write down the other two. For part B, we're looking at the probability that the tread life is somewhere between 40,000 and 60,000. So that is probability P x between 40 and 60. And as an integral, we get this guy. And finally, we have in part C, the probability for greater than or equal to 70,000. So P x, x bigger than 70, which will be 70 to infinity f of x dx. So we'll need an improper integral for that one. Okay, part A. So part A is this integral here. Now, I can see that I'm going to be doing this integral of f of x 3 times, so why don't I just think about what that's going to be. So the integral, let's say the indefinite integral of f of x, is worth doing on the side. So that's the integral of 0.02 e to the negative 0.02 x dx. Now I would do a u sub. U is negative 0.02. So dx is going to be du over negative 0.02, giving e to the u du over negative 0.02. So what I get here is negative of e to the u, we'll say plus c, so that's negative e to the negative 0.02 x plus constant. So we're going to be doing these 3 integrals above, and we're going to be using this guy right here as our antiderivative, capital F of x. And just to clarify, that's some ugly looking numbers there. Let's fix them up. 0.02. Okay, let's keep that guy in mind as we proceed. Part A. We're doing this integral. And we get, well, that's f of x from 0 to 30. And f of x is found below, which is this guy. Let's write that down, negative e to the negative 0.02 x from 0 to 30. Plugging this in, I get negative e to the negative 0.6. And then when I plug in the 0, I get minus 1. give me 1 minus e to the negative 0.6. And I plug this into my calculator, and I get about 0.4512. Okay. Part B. Let's take part B out of its prison here. Move it down here. Okay, same idea, but you got a capital F of x, which I very conveniently found before. Why can I not do my x's? Careful, 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 Jordan. You're always rushing, and it makes no sense. Okay, plugging this in. What do we get? We get negative e to the negative 1.2 plus e to the negative 0.8. This is a plus here because of a double negative, right? You have the negative that appears in your antiderivative, and you also have the negative that appears in the fundamental theorem of calculus formula. Anywho, working this out, I get roughly 0.1481. So roughly 15% chance there. C. So here's my part C. Bring that down here. So this one's going to require an improper integral because I got that infinity there. So I straight away bring in a limit, t going to infinity. Set up my improper integral as usual. So I got f of x, capital F of x, from 70 to t. Limit of that, which is limit of, now what was that function again? E, negative e to the negative 0.02 t plus, then when I plug in 70, I get negative 1.4. Then t is going to infinity. So this guy goes to 0. This guy doesn't change. And this is approximately equal to 0.2466. So a 25%, roughly 25% chance that a tread chosen at random will last more than 70,000 miles.